point this is the vertex of the parabola, and then you can see that the parabola opens up towards the focus, and the directrix is the line that's down here, and the focus and the directrix are an equal distance away from the parabola. The distance from the vertex to the focus is p, and how you find this is x minus h squared equals plus or minus 4p y minus k, and h and k is the point at the vertex. So it'd be h, comma, k at the vertex. The question says, write a function with a vertex at the origin and focus at 0, 4. So then you draw in your coordinate plane, and here at 0, 0 is our vertex, and then up 4 would be our focus at 0, 4, and then down 4 at 0, -4, we'd have our directrix, and then from there you just plug it into the equation. So it'd be x minus 0 squared equals plus or minus 4 times 4, because p is the distance from the focus to the vertex, and then you'd have y minus 0.
So the problem is, write an equation in general form where vertex is at 5, 2 and directrix is at y equals 5. So right off the bat, if it's at 5, 2 and y equals 5, you know the distance from 2 to 5 is 3, so you know p equals 3, and the equation is x minus h squared equals plus or minus p 4p y minus k. So we already have p here, and that would be substituted right here, and then h is 5 and k is 2. So the equation would be x minus 5 squared equals plus or minus 4 times 3, which is 12, and then y minus 2. So that would be that. And so if we'd graph this to check yourself, we would have, so let's say this is 1, 2, 3, 4, 5, 1, 2. So here's the vertex, and y equals 5. So 3, 4, 5. And so here, this graph would be opening down because it opens away from the directrix. So it'd be like this. And this distance, p, is 3, and that'd be it. Alright, so our problem is write the equation in general form, and we're given this graph here with the directrix at 0, 6, and the focus at -3, -8. So if we write our equation in general form without the values, we have no k or h or p actually. So we can use the value we find for p in order to figure out our h and k, our vertex. So we know that the distance from the directrix to the vertex, wherever that might be, right here, around here, and the distance from the vertex to the focus is the same. So directrix to vertex and vertex to focus is the same. That means that directrix to focus over 2 is that p-value we want, directrix to vertex. So 6 to 8, -8. That's a distance of 14. So 14 over 2, and we get 7. So if we go 7 down from the directrix or 7 up from the focus, either way, we get -1. So we know that our y of the vertex is -1, so right here. And to find x, we look at the focus, and we see -3 in the x, and we know that it will be on the same line as the focus. So we know that our vertex will be at -3, -1. Okay, and we also said that this distance P, directrix to vertex, equals 7. So now we have HK and P. So all we need to do is plug it in the equation. So x minus -3 squared equals plus or minus 4 times 7. And then y, let's move that down here. So we have y minus -1. So if we simplify, we know x minus -3 is the same as x plus 3 squared equals 4 times 7, which is 28. And then y minus -1 is the same as y plus 1. And this will be your equation in general form. So we figured out our answer, and just to finish this graph off, we know that it will be going like this, if you really wanted to finish your graph, because it opens into the focus.